So you can message me directly, but it's better if your questions go out to everyone because we want everyone to see everyone's question. Cool. So without further ado, are we ready to begin? Give me a thumbs up if you're ready to get going. Right? Give me a thumbs up if you're ready to get going. I want to see lots of thumbs up. Right? Cool. Fantastic. Well done, everyone. So we're good to go. We're good to start. Thank you, guys. So we're going to begin with 3.1. So what are we doing today? We're doing Unit 3. And guys, I'm going to be focusing very much on the models, on the graphs, and on the nitty-gritty, okay? There are sometimes theory details, you know, like some history stuff or whatever. That's quite easy to read. And you need to make sure that you check your unit, that you check your lecture slides specifically for any little details that I might have left out. The lecture slides are, you know, what's important. So just always make sure to go look at the lecture slides, and if there's anything that I've left out, you just fill it in. But I can promise you by the end of this, all the really hard stuff from Unit 3 will be a lot easier for you. So that's just my one caveat, is that I obviously in 2 hours cannot incorporate every single detail that is in the unit. So with that said, we're going to get going now with 3.1. All right. So with 3.1, we're looking at labor and production. Okay, we're looking at labor and production. Now, you should have all received some notes, actually, before I begin. If you haven't received the notes, I'm going to mail it to you. I'm going to drop it in the chat box right now. The notes are very limited. So in the notes, what we do is I just put together essentially a glossary. Okay, so when it comes to definitions, all the big definitions are going to be in the notes. The notes are about to appear in the chat box, so just uploading now. So just make sure that you've got those, and you know sometimes it's not necessary to write down a certain definition. So the first one is our ceteris paribus. So the first thing I just want to make sure everyone understands is this idea of ceteris paribus. Okay, so ceteris paribus means holding all other variables constant. So in economics, we're very interested in learning about the different dynamics that exist. And in order to understand, so in other words, how does one variable affect another variable? Those are the dynamics, right? Lots of different connections between different variables. So ceteris paribus is we say, when we say, cool, hold everything constant and only change x. Then let's see what x changes, right? Does x change y? Does x change z? And what is the impact that x might have? So ceteris paribus is holding all things constant. So we use this in experiments to see what the effect of that one thing might be. Give me a thumbs up if you understand this and if you're ready for me to move on. All right? Give me a thumbs up. Awesome, guys. Cool. So now that's just some side note stuff. Moving on to labor and production. So I want you to draw 2 graphs. Okay? I want you to draw 2 graphs, one on top of the other one. All right? One on top of the other one. So graph 1, actually, I'm going to do them here. We've got graph 1, and we've got graph 2. All right? Over here, we're going to be measuring Q. Down here, we're going to be measuring L. And over here, it's going to be AP and MP of L. And here, it's going to be L as well. So you're going to learn about what all these things are in a second. Okay? But I just want to make sure you've got your graphs sorted out. So what we're going to be looking at now is the production function. Okay, and what the production function is, and again, it's in your notes, the wordy definition, but it basically shows a relationship between Q and L. Okay, where Q is output, produced, okay, output, and L is labor. All right, so here we know that in this situation, Q, right? Q is dependent, L is independent. Okay, so we've got Q and we've got L, where essentially what we're trying to say is Q output is a function of labor. Right? Q is my function of labor. Does everyone understand what I've written on the board? Give me a thumbs up if we get what's going on here. Otherwise, just ask me a question or ask me to go back if you need me to. Okay? So again, basically, we're just saying the production function shows a relationship between Q and L, and we say Q is a function of L. So Q is dependent and L is independent, right? Now, let's begin drawing our production function. So the way that we draw the production function, right, we see that it curves. It goes up, but then it increases at a decreasing rate. So Q as a function of L. That is my production function. Cool. So what do we see here? That the slope is decreasing as we move up, and we will explain why this happens in a moment. But I just want to make sure that you guys get this. Okay, what does the AP and the MP mean? Abigail, we're going to get there now. Okay, so we've got our production function, which increases at a decreasing rate. All right, and now we're going to define AP and MP. So marginal product, MP, right, is what we call marginal product, and it's in your definitions list. So make sure that you look at it. But it's the extra Q from producing, from hiring one more L. Okay, so marginal product is the extra output that we get from hiring one more unit of labor. Cool. So numerically, what is that going to be? It's going to be equal to the change in Q divided by the change in labor. Right? If I hire more labor and I get some more output, then I'm going to look at the change in quantity and I'm going to divide it by the change in labor, and I'm going to know what my marginal product is. Does everyone understand this basic definition of marginal product? MP is marginal product. Give me a thumbs up if we get this. Yeah? Cool. I'm waiting for some more thumbs up to know that I'm good. Otherwise, ask me questions on the graph. I will be erasing some things as I go along so that we can keep working here. All right, sweet. So we understand it. Cool. So marginal product, the change in Q over the change in L. Now, tell me, guys, right? Answer my question. What is the slope of any curve where you've got Y and X? The change of what over the change of what? Anyone? What are the two whats? Change of what over the change of what is my slope of any line? Anyone? Okay, maybe it's a bit, yeah, there we go. Change of Y over the change of X. Thank you very much. What's on my Y-axis here? Right? Q. What's on my X-axis here? L. So change Q over change L is change Y over change X. So the marginal product is always going to be equal to the slope, right, of the production function. Okay? Our marginal product is equal to the slope of the production function. So we can always look at our slope here to see what marginal product is. Finally, right, not that I don't think you guys are ever really going to have to deal with too many derivatives, but just in case, it's also equal to the derivative of the quantity function in terms of labor, right? So we can see it as the slope of the production function. We can see it as the derivative of the production function, which is the slope. We can see it simply as change Q over change L if we were given numbers, right? Or in words, it's the extra output that we get from hiring one more labor. Is everyone happy with this? Are there any questions? Cool? Give me some thumbs up if we're good to go. Awesome. Awesome. The next one then, right? The next one is my average product, right? So we've got average product. And average product is pretty simple. AP is equal to Q over L. I'm not even going to go into much more detail about that. Average product is the average product we get per laborer. So if I produce 100 units of output and I've hired 5 laborers, I'm going to take 100 divided by 5, and on average, every laborer produced 20 units of output. Is everyone happy with average product and marginal product now before we start adding numbers to our example? Going once, right? Going twice, we're good. Okay, sweet. So we've got AP and MP here. And basically, we're going to start adding numbers to make sense of this. So I'm really not going to go far. I'm going to go 1, 2, 3, 4, and 5. Okay, so take that up. Okay, we're going to add some numbers on this side now as well. Okay, if your numbers, if it's not perfectly proportional the way that you draw the numbers, don't stress too much about it. Okay, don't stress too much about it, but basically we're just going to say 30, and then 50, and then we're going to call this 60, 65, and then actually what I want to do here, if you don't mind, guys, I'm just going to make a little edit here, and I'm going to curve this so that it goes straight. Okay, I'm going to curve, oh, sorry, I'm going to curve it here. So it's just a small edit. It's just a small edit. I'm going to curve it there so that this is the same. Everyone can see that. Okay, it's just an important thing to note. Cool. Is everyone happy? Any questions about what I've drawn? Can we see properly? Everyone's good to move on. All right, cool. So now what I want to do is I want to plot marginal product. I want to find my marginal product. So let's first just do the maths, right? So what is the marginal product when L is equal to 1, right? So just so you can see my notation here, I'm saying marginal product with a subscript L equals 1. So marginal product when we have labor equal to 1, right? So we could just put MP1 if we want to. So how do I calculate marginal product? Well, I basically look at what was the change in Q that was caused by hiring another laborer. Okay, what was that change in Q? So quantity increased by 30, right? We went from 0 to 30, so it's 30 minus 0 over 1. And I'm able to see that the marginal product of the first worker is equal to 30. Cool? Then marginal product of labor equal to 2. That's going to be equal to the change. So when I go from 1 to 2, everyone, when I go from 1 to 2, I see that I increase. So I increase my laborers by 1, and I increase my output by 20. Okay? How do I calculate that 20? It was 50 minus 30 over 1 is equal to 20. And so on and so forth. So I'm not going to quite go into as much detail now. The marginal product of the third laborer we see is an extra 10. The marginal product of the fourth laborer we see is a change from 60 to 67, which is 7. And then finally, the marginal product of the fifth worker is equal to 0, right? Because when we go from 4 to 5, we get nothing extra. Does everyone follow the maths and how I calculated marginal product here? Please give me a thumbs up if it's good. If it's not good, ask me a question. Ask me to run over it again if you need me to. Right? So I'm just waiting for everyone to give me some sort of reaction or a question. Otherwise, I'm going to move on now. Fantastic. Okay, so let's now graph this. Okay, let's graph this. So we're going to take these numbers down, 3, 4, and 5. So I've got 1, 2, 3, 4, and 5. Okay, and now I'm going to start. Doing my marginal product numbers. So we calculated the marginal products along the way. I need everyone to focus with me. So yeah, I'm going to answer that question now. I need everyone just to watch this. It is a minor detail that is not that important. Okay, it's a minor detail that is not that super important. But if you don't watch me, you're going to get confused about what I'm doing because I like to do things properly. All right. When I plot the marginal product of the first worker, what I'm really plotting is the change in output when there was a change from 0 to 1. So rather than rather than plotting it on the 1, I plot it in between. Okay? I plot it at half. Because this represents, so this is going to be my 30. This represents the change from 0 to 1. Okay? This represents the change from 0 to 1. Likewise, right? When I plot the marginal product of the second worker, I'm going to do that in between, right? In between 0 and, in between 1 and 2, because it represents the change from 1 to 2. It is the marginal product of the second worker, but mathematically, right, when we plot a derivative, which is what marginal product is, we plot it in between the numbers, 0 to 1, 1 to 2, and so on and so forth. Give me a thumbs up if everyone's happy with that, that detail that you've just got to kind of understand, just to make sure that you don't get confused, right? If you see it at half, it's connected to 1. If you see it at 1.5, it's connected to the second one. Awesome. So we can plot this now. We've got marginal product of 30, marginal product of 20. Then we're just going to put a 10 in there and a 7, and then we drop straight down to 0. So the marginal product of the 10th is here, 7 is here, and 0 is here. So there is my, right? There is my marginal product curve, MPL. So the question that came through was, is marginal product diminishing from the beginning? And the answer is yes. So very good. We do see that marginal product is diminishing from the beginning. And we are going to make notes on that just now. So for those of you who are worried about that, don't worry. We'll be working through it in a second. Is everyone happy with this? Give me a thumbs up if I can move on to the next section, to the next part, which is about average product. Going once, going twice. All right, cool. So I'm going to erase these numbers just because they're going to get in my way. So now we can calculate the average products as well, which I'm going to do quite quickly. So we can see that the average product of the first worker would be equal to 30 over 1, which is equal to 30. The average product of the second worker is going to be equal to, or the average product of 2 workers. I shouldn't say the average product of the second worker. The average product of when we have 2 workers is equal to 50 divided by 2, which is equal to 25. The average product of the third worker is equal to 60 divided by 3, which is equal to 20. Average product of the fourth worker, we've got 65 divided by 4, and the average product of the fifth worker is equal to 65 divided by 5, all right? Which are equal to 16.25 and equal to 13. Cool. So we've got those numbers, and then if we want to, we can graph those as well. Now, I don't want to spend too much time drawing lines on the board because I don't think it's very necessary. But essentially, what you would do now is you would put your average product, right? You would put your average product on the 1 line. So 30 for average product of 1, 25 for the average product of 2. So that's 25 there. Okay. Then we've got 20 for the average product of the third one, right? 16.5, right? And 13 would be somewhere along there. So we can see that that, right, is my average product of labor curve. Is everyone comfortable with that? You can fill in the numbers if you want to, right? I don't want to spend too much time on that at this time. Should the MP and AP line be drawn freehand with dot to dot in a straight line? I wouldn't stress too much about that. But if you were to do it, I would go dot. I mean, if you want to make it perfect, I would go straight line from one dot to the other dot. Okay? Not straight through, it's not like a regression line, but straight. But I mean, I do it all freehand, and I think it's absolutely fine. If I was in an exam, I would just do it freehand. Okay, is there any relevance of the points AP equals MP in a situation where they cross? No. So given what you've drawn here, what you can see is the only time that they're going to converge is at 0, right? So because the production function increases immediately at a decreasing rate, right? Then in this situation, we don't see in this example a relevance between MP and AP being equal. If we had a different shaped production function, right, then it is possible. But in Unit 3, they only focus on a production function that immediately increases at a decreasing rate. In other words, it has diminishing marginal returns from the very get-go. Do you understand that? Give me a thumbs up if that makes sense to you and if I've answered your question there, right? Cool, awesome. So we're going to move on. Sorry, something just came on my screen. All right. Cool. So let's begin. Let's carry on with our notes here. So what I want you guys to note of the main things, the main things that we've seen here is that this production function, the production function exhibits, right, diminishing marginal returns. Okay, diminishing marginal returns. What this is saying is that as labor increases, the marginal product, so as labor increases, marginal product of labor decreases. Therefore, quantity increases, but at a decreasing rate. All right, I hope that makes sense to you guys. So the production function is exhibiting diminishing marginal returns, which means the extra quantity that we get as labor increases gets smaller and smaller and smaller. So output increases at a decreasing rate, marginal product of labor continues to fall. Does everyone understand this? Are there any questions? Give me a thumbs up if we understand this. Okay, questions, chance for questions now. Does anyone have a question for me before I move on to the next section? Everyone's happy. Everyone's happy. Okay, cool. So that's the production function and marginal product, average product. They love to ask questions about this. I'll tell you, before they switched to the core syllabus, this was still included, which means that if the lecturers get lazy and they want to use old questions, they're going to ask you questions about this kind of stuff. So make sure you understand the insides and outs of this. I think there's a lot here you can see. If you give an average product, you could multiply by the number of labors to get your total output. If you add up the marginal products, you'll get it. And you must be able to just move between these graphs quite freely. Okay? So I had a question from Abigail. Should more employees be employed when marginal product is 0, when the production function decrease? So guys, when we hit 0, it just means that another laborer does not add value. But how many workers we hire is going to depend on the wage rate. So that's something you're going to learn later on, okay? But you can't answer the question, how many workers should we hire, by looking at this, because we don't know how much a worker costs. And in order to figure out how many workers we should hire, we need to know the benefit, which is here, and the cost. But we also don't know the price of this output. So let me know if that answers your question. Sorry, I see now the private message. So just pop me a yes if that answers your question. You cannot determine the number of employees to hire, but you definitely are not going to hire anything more than these 5 employees, because the 5th person adds nothing. So actually, you're not going to hire past the 4th employee. The 4th employee is the max you'll ever hire. Okay? And how many you will hire, we don't know, because we don't know what the situation is in terms of wages, and we don't know what the price of this output is. Cool. If everyone's happy, I'm going to erase the board now, and I'm going to move on to preferences, utility, and difference curves. Going once, going twice, and we're good to go. Cool. Awesome. So, the next section, preferences, utility, and indifference. So, put the production function in your pocket because it's going to come back later. So just keep it there, keep it top of mind, right? And we will come back to it in a second, and we will be using it in our analysis. So the second thing that we're doing now, 3.2, is all about preferences, utility, indifference curves. Okay, preferences, utility, and indifference curves. So what is utility? Okay, what is utility? I don't think I'm going to write it on the board because you do have it on your notes. Has everyone been able to find their notes? Are there any questions? Okay, so if no one says that they can't find their notes, I'll assume we do. So what is utility, right? So utility is the satisfaction that we gain, right, from an outcome, a product, or something like that, okay? So we get utility. Now, if we looked at utility on a graph, utility, and we'll call this Q, this can be anything from a product, this could be a product, or an activity, etc. Okay, we can graph utility here. Now, I want to ask you a question, guys, and answer me this. When you have a pizza, is the first piece of pizza as tasty, or no, let me change it around. When you have a pizza, is the last piece of pizza give you as much satisfaction as the first piece of pizza? Yes or no? Just answer that question, right? The last piece of pizza gives you the same satisfaction as the first piece of pizza. No, right? So when I eat I'm really hungry and I eat my first piece of pizza, I get a lot of satisfaction. Do you think that the second piece of pizza gives me as much satisfaction as the first piece, right? So do we think that the second one? No, right? Exactly. So when I have pizza, right? My first piece of pizza, it gives me lots of utility. So it's just like what we drew earlier, the production function. I get a lot of utility from the first one, a little bit less from the second one, and so on and so forth. So utility looks a lot like the production function, okay? It increases at a decreasing rate. So we could then draw what we're going to call marginal utility, where marginal utility is equal to the change in utility over the change in Q. In other words, the extra utility from one more Q. So as I consume one more piece of pizza, I can measure the extra utility from each additional unit of pizza by looking at marginal utility. By taking my total utility and saying, what was the change? And then dividing it by the change. So we can see that marginal utility, right? It decreases as we consume more, and that relates to the graph that's right above. How are we doing? Give me an answer if this makes sense to you guys. Give me a thumbs up if it does. Okay? So the main thing to get out of here, is marginal utility decreases as Q increases. And this is what we refer to as, right, diminishing marginal utility. Okay, diminishing marginal utility. And I think that it's really important that you guys understand this, because it's going to be a fundamental part of what we learn. And we're not going to be graphing MU and U. This is the last time you're going to see these graphs. Okay, so I'm going to explain everything to you guys in a second now. I'm going to answer those questions, but this is the last time you're going to see this graph. So what exactly is the top graph? Isn't utility represented by indifference? So thank you for the question, right? So utility itself is not represented by indifference curves. Indifference curves show the combinations of two goods that give equal utility. So utility is never actually on the graph, right? We just assume something about utility. We're going to discuss indifference curves in depth now. So all I'm trying to get here, basically, is just to show you that we have diminishing marginal utility. The most important thing that you get here is the diminishing marginal utility. And I'm just using these graphs to represent that. Utility increases at a decreasing rate, which means marginal utility decreases as Q increases. This is not an indifference curve. Let me know if that answers your question. Okay, give me a reaction or an answer. Cool, awesome. So if that's it, if anyone has any questions, I'm going to erase the board now. Going once, going twice. Okay, cool. We're gonna get into the stuff that's really important now. So we know that diminishing marginal utility is something. Okay, it is something that we have to remember, that there is this diminishing marginal utility. So you now are going to learn about indifference curves. So what is an indifference curve? An indifference curve shows combos of two goods, outcomes, etc. Right? So it could be anything, right? Combinations of two goods or outcomes, etc. that result in equal total utility. Okay? So essentially, I'm just looking at what are the combinations of pizza and Coca-Cola that are going to give me the same utility. Maybe it's a half a pizza and 2 Coca-Colas, or it's 1 Coca-Cola and 3/4 of a pizza, or 0 Coca-Colas and a whole pizza, etc., etc. So indifference curves, right? We measure it like this. Let's say that this is Y, so this could be anything. Y can be anything, but what we're going to be working with is consumption, right? And actually, no, I'm going to erase that. Don't write that down. Let's just call it Y and X. So Y could be a product, X could be Y could be a product, X could be a product, or Y could be an outcome, X could be an outcome. Okay? And my indifference curves here, right? My indifference curves. So if I draw an indifference curve, I'm going to answer the question. There's a direct part of the question I'm going to answer now. So what this is showing is that all the combinations on this line of Y and X give me the same utility. So if I have this much Y and X, or this much Y and X, or this much Y and X, I have the same utility. Therefore, I'm indifferent between them, right? This one, this one, this one, they're all the same to me. I'm going to have the equal amount of utility. Give me a thumbs up if everyone understands this, please. Right? Just give me a thumbs up if we follow this explanation, or ask me to repeat it again if you need to. Okay? So, any questions? Everyone's good. All right? Matt, does utility increase at a decreasing rate? Yes. That's why we drew those graphs earlier. Cool. So, indifference curves. Now, we've said that every unit, every bit along an indifference curve, right, is going to give me the same utility. But what do you guys think? Look up at the board. Look up at the board, right? So marginal utility is the same as the slope of different points on the indifference curve. No. So guys, I'm going to ask everyone now to just not think about anything I don't say. Okay? So Olivia, I'm not going to even answer that question. I'm just going to say to that question no, and I don't want you guys to think of anything else. You will understand the relationship between them all at the end. Once I reach the end of the section, then if something's not clear. But no, marginal utility is not the same as the slope of the different points in the indifference curve at all. You're going to see in a moment where it comes from. So let's get back to it. I want you guys to answer my question. Okay? I want you guys to answer my question. Do you think that I would be happier if I went from this point to this point? Yes or no? If I could have more y and more x, would I be happier? Yes. Okay? The answer is yes. So now we would have to find a new indifference curve that shows new combinations of x and y. So this is going to be IC2 and IC3, and so on and so forth. Okay? Does everyone follow this? Are there any questions? Give me a thumbs up if this makes sense to you, and then I'm going to move on. Cool. Thank you, guys. So we've got the indifference curves. We're going to write down all the rules in the indifference curves in a second, right? But let's just draw this. So I'm going to address now, Olivia, that the thing about the slope. So you're interested in the slope, which is very good because the slope is really, really important. Okay. We draw. Let's just draw a little slope representation. Change y, change x. Okay. So I should do it in red. Change y, change x. So my slope of the indifference curve, right? The slope of the indifference curve, what it represents is the change in y over the change in x that ensures that total utility remains constant. Okay? So the slope of my indifference curve is going to be equal to the change in y over the change in x that ensures that total utility remains constant. I'm going to give up this much y, and I'm going to get this much x, and I'm going to stay equally happy. And we refer to that as the marginal rate of substitution. Okay? It's the rate at which I will give up y, I will substitute y for more x and maintain total utility that is constant. That is, remember, the whole point of an indifference curve is that we have equal total utility at every point on the indifference curve. So by like basic logic, because of that definition, I now know that the slope of my indifference curve tells me the rate at which I can trade y for x and keep total utility constant. And that is what we refer to as the marginal rate of substitution. Okay, so give me a thumbs up if you guys understand this. We're going to write a little bit more about it, but give me a thumbs up if you understand this. Ask me a question or tell me to just go through it one more time if you need me to. Okay, but we do need to move forward. So if you feel like you're pretty good sure about it, we're going to move on. Okay, sweet. So carrying on, I'm going to erase here now. I just want to say, so what is my MRS? We said it's the MRS is equal to the change in y, change in x, with utility constant. Now, this is going to be a little bit difficult at first to understand, but you're going to get it. So be with me. If I'm willing to give up 2 y's for 1 x, okay? So let's say that the numbers were 2 and 1. Let's say that this was a 2 and this was a 1. If I'm willing to give up 2 y's for only 1 x, and my utility remains the same, it means that the 1x is going to give me the same amount of utility as the 2 y's combined. So the 1x, therefore, gives me double the utility of each one of those y's. So if I'm going to repeat it again, I'm going to say, if I'm willing to give up 2 y's just for 1x, it means that each x is going to give me twice the marginal utility of 1 y. That's why I'm willing to give up one, and that's why I'm willing to give up 2 y's for just 1 x, because I value x double the amount that I value each y. Do we understand that? Give me a thumbs up if you guys are following me, right? So I'm willing to give it up 2 for 1 because I value x 2 times the amount that I value y. Remember, x valued 2 times what I value y. So this is going to be equal to the marginal utility of x divided by the marginal utility of y. I value x twice the amount that I value y. So it's not MUY over MUX. It's MUX over MUY. Because if I value x 2 times the amount that I value y at the margin, then I'm going to give up 2 y's for 1 x, and I'll be equally happy. Do we follow? Give me a thumbs up if everyone understands this. If you do, right, then we're going to move on. Okay, sweet, guys. Thank you all very much. So let's get through the main points of the difference curve so that we can carry on. We've got a lot to do today. Today's quite a thick workshop. There's a lot of content. So we just want to make sure we know. Some of this is in your graph. So the rules for indifference curves and characteristics of indifference curves. Okay, the first one, right, is that they are downsloped due to the trade-off to keep U constant. Okay, so they are downsloped. Why? Because, like we said, if I move from one point from here to another point, in other words, if I were to move in an upward sloping direction, right, I'm obviously going to be more satisfied because I'm getting more of both. So in order for utility to be constant, if I take away y, I must give you x. Or if I give you more x, I have to take away y. Otherwise, my utility will not be kept constant. So a trade-off is required, right? They have to be downward slopes. The second thing is that higher indifference curves, right? Higher indifference curves means higher utility. Since we basically get more of both. Okay, so higher indifference curves represent higher utility because you're going to get more of both when you move up the indifference curve. We've already spoken about that. Okay, the third one is indifference curves usually are smooth. Okay, so indifference curves usually being smooth means that a small change in x or change in y does not result in large change in utility. Okay, so that's not it's a kind of a weird one, and I wouldn't worry too much about that. It's basically just saying that when you get more of something, you don't have massive jumps in your utility numbers. Cool. So does everyone understand these 3 points? We've still got 2 more, but I just want to make sure before I move on that we're all good with these 3 points. Ask me a question if you want to about these 3 points. Right? Now's the time to ask me a question about these 3 points if you have one. Cool. Going once, going twice. All right, sweet. So the next thing is, the fourth rule is that they are convex. Okay, so where are we? Convex. Indifference curves are regularly convex. Okay? I'm saying regularly because when y and x are just kind of normal types of things, then it's convex. But there are situations where they are not convex, but you guys don't really need to know much about that. Okay, so why are they convex? The best explanation is with a graph. Okay, so we're going to put y and x here, and I'm going to look at a single indifference curve. Okay, so answer me this, guys. When I have a lot of y, and I have little x, so look, I'm at this point, right? What do you think I value more? An extra y or an extra x, right? So great, so a few more answers. If I have lots of y and I have very little x, right, I'm gonna value extra x more, okay? So that means that I'm gonna be willing to give up lots of y for just a little bit of x, right? Willing, so give up lots of y for little x, right? And as x increases, right? As x increases, this changes. Now, when I have a lot of x and very little y, I see that it's the other way around, right? I'm not, if you want to take y away from me, you have to give me a lot of x in order to make up for it. And that is where we see convexity. That is why our indifference curves take this shape. Because as y decreases and x increases, the MRS, remember, the MRS decreases. As y decreases and x increases, the MRS decreases. In other words, the change in y over the change in x that keeps utility constant, right? So we see there's a decrease in the amount of y that you need to give me for x to keep utility constant, right? There's been a decrease, right? Because I don't have a lot of y and I have a lot of x. So this changes. Give me a thumbs up if you understand convexity. Please give me a thumbs up if you understand convexity. Cool. Right? Another way you can see it, I actually just want to mention this, right? Another way you can see it is that up here, marginal utility of y is high, right? And the marginal utility of x is low, right? So if the MRS is equal to MUX over MUY, right? Then if this is high and this is low, then the MRS is going to be low. And you can see that. It's a steep line. It means that the absolute value of the slope is is quite small. Okay. Sorry, MU. This was an error. Apologies. MUY is low and MUX is high. And therefore, the MRS is high. Sorry, you might have been getting confused there for a moment. So cool, everyone's good. So the equation of the slope is the change in y over the change in x that keeps utility constant. But this is MUX over MUY. This is not change. This is not change in x. Okay, so cool. So I'm just going to address these questions. So I'm reading. I understand that the MRS decreases, x increases, and y increases, but the slope increases because it becomes less negatively steep. So thank you. Thank you for, I was actually about to think, we are dealing with the absolute value of the slope of the indifference curve. So just everyone take a step back in their notes. The MRS, right? The MRS is equal to the absolute value of the slope of the indifference curve. Okay, So apologies for that error. Please make sure that you note that in your things, and then we will carry on. Does anyone have any questions, or can I move forward? We still got quite a bit to get through, so I do want to get going. Going once, give me some thumbs up. Going once, going twice. Cool, we're good. I'm going to erase the board now. Great. So we got a lot to get through, but we'll get there. So the last thing, the fifth rule that we were going to cover is indifference curves cannot cross. Okay? Indifference curves cannot cross. And the indifference curves cannot cross. And so what does that mean? How do we know this? We're just going to set up a situation and pretend like two indifference curves crossed. I see one, I see two. So let's say we have this A, we call this point B, and we call this point C. Make sure that C is out and to the right of A. Okay? I'm gonna address the private question now, just now. So A, B, C. So indifference curves cannot cross, and we simply use this to prove that. So we say A equals B since both on IC one. Is everyone happy? So in terms of utility, in terms of my utility, A equals B because they're both on IC1. Okay? They're both on the same indifference curve, so I'm equally happy with them. The second thing is that B must equal C, since both on indifference curve 2. And remember what I mean here, I mean in terms of utility. Okay? So A gives me the same amount of utility as B. B gives me the same amount of utility as C, since both on indifference curve 2. Therefore, right, A should equal B should equal C. So in other words, A should equal C, right? But guys, tell me, if C has more of both Y and X, can C be equal to A? Can C be equal to A if C has more of both? No, right? No, it can't be, right? But not possible, right? C is greater than A because it has more of both. So it simply cannot cross. All right? So this is the, if they ever ask you to explain why they can't cross, this is exactly how you would do it. The only way that you're able to do it. Give me a thumbs up if you guys understand me, and we can move forward here. Give me a thumbs up. Cool. So there was a question about absolute values. What an absolute value, guys, is just to drop the negative. So the absolute value of -4 is 4. The absolute value of -0.5 is 0.5. So an absolute value takes anything and makes it positive. If it's negative, it's positive. If it's positive, it stays positive. So give me a thumbs up, person who asked me that question about absolute values, so that we can move forward. Cool. All right. I think that should explain it. So we have finished this part. If anyone has any questions, pop me an answer now. Otherwise, we're going to move forward. Yes, the MRS will always be positive. The slope of your indifference curve will always be negative, but you're always going to take the absolute value of that. The MRS is always going to be positive. And we always say it's the rate at which I'm willing to trade Y for X. So you don't need a negative to tell you that. If it's 5, it means I'm willing to give up 5 Ys for 1 X. Let me know if that answers your question, if you're happy with it, if you're satisfied with that. Okay. I hope we're good. Going once, going twice. Done. All right, guys. I'm going to make a strategic decision now. And I'm going to tell you all to cover 3.3 on your own. All right? Please review 3.3 3 on your own, you're actually going to see that they're in the all in the definitions. 3.3 is about accounting cost, opportunity cost, economic cost, and economic rent. Okay, these are 4 definitions which you're going to see inside the notes that we've sent, but it's just not worth it for me to go through it with you now in terms because of time. There are more difficult things that I would rather focus on. So we're going to skip 3.3. Please make sure that you cover it on your own, and let me know if that's all good. Give me a thumbs up if everyone's happy with that. Okay, give me a thumbs up if you're happy with that. We will talk about opportunity costs now, but I'm not going to talk about the whole 3.3. Please understand that you're going to be very happy I did this when we get to the next sections, which are much more difficult. Cool. You're going to have an answer to that question. What's the difference between opportunity cost and MRS just now? Okay? The MRS is not the opportunity cost. All right. Sweet, guys. So we're going to move to 3 point, and we will take a break shortly. We will take a break shortly, but I want to get this 3.4 done before we do that. Okay. 3.4, the feasible frontier. Right? The feasible frontier. Okay, so what the feasible frontier is going to show us is what are the various options that we can have. So we're going to define it just now, but what we did just now, think about what we did with indifference curves. With indifference curves, we were looking at what are the options that yield the same utility. So they were theoretical. It was like, this many pizzas, this many Coca-Colas, they give me the same utility. And, you know, it was very theoretical. It wasn't about what we can have. It was about simply what would make me equally happy. Now we're going to look at what is possible. What can I have? What are my options? Okay, and then we'll be using that in combination with the preferences and the utility to take a look at what is possible. So what is the best for me to choose? Are we good with that? So I hope that everyone's okay with that. So going back to your production function, Q and L. So remember, we're going to think of this as work hours. And we know that how much output I produce, right? How much output I produce is dependent on how much I work. And then what's the maximum that you can work in one day, guys? Anyone? What's the maximum that I can work in one day? Okay? You can't actually do it, but in theory, you could work 24 hours. Exactly. So 24 hours is where this ends, and this is my production function. Now, what we're going to do is we're going to turn this into a feasible frontier. Okay? We're going to put Q here, and we're going to put leisure hours here. And what I want you guys to see is that work hours equal 24 minus leisure hours. Or we can think about it the other way around, right? Leisure hours equal 24 minus work hours. So the maximum leisure I can have is going to be 24, but I will get 0 because I'll be working 0 amounts of work hours. And then, right, these would essentially match up, right? This point here and this point here would show the various options that I have. And this is what we would call the feasible frontier. Okay, this is what we call the feasible frontier. It shows the various options, right? It shows the various options that we are able to have between output and leisure hours. Okay, now everything on the inside is feasible, right? But it's not optimal. It's not efficient, right? So we want to be sitting at points here. So anything on the inside, we're going to call that A. B, C, and we're going to call that D. Okay? So if we're at A, feasible, but can increase, right? But can increase Q without any decrease in leisure. Okay? So that's A. A, we're able to have more output and we don't have to decrease any leisure, right? Then we're going to see we've got point B, right? Point B and point C. Actually, I'm going to just write it here. Point B and C, we cannot increase Q without decreasing leisure, and vice versa. Okay? So you cannot increase quantity without, this is without, right, a decrease in leisure when I'm at B or C, right? So that means that I am where I am going to be efficient, which is something you're going to learn about in later section. Finally, we'll see that D is not possible. Okay? D is simply not possible. So, do you guys understand this basic concept of the feasible frontier? Give me a yes if you do. Or give me a thumbs up. Sorry, you don't have to say yes. Give me a thumbs up if you understand. Okay, if there are any questions, let me know now. So A is a big waste of time. We ignore A. We'll never be looking at A ever. We'll only ever be looking at things along the feasible frontier. A is a waste of time. D is also a waste of time. So is the mirror of the feasible frontier a production function? Yes. The answer is yes when we're looking at the difference between output and leisure hours. Okay? So only if we have output and leisure hours, then it's a mirror. Right? Just now we're going to change things up a bit and we're going to look at other things. Okay? Like consumption. But when it's set up like this, it is a mirror. The answer is yes. Okay, cool. Do you guys feel like you need a 5-minute break? We do take a 5-minute break usually in the middle of the workshop. So just, yeah, I see a thumbs up there. Is everyone else? Okay, cool. We're going to take 5 minutes. So it's 14:39. We're going to start again at 14:44. So that's in 5 minutes. I want you guys to be aware that we are likely to run over time today. Okay, so as in the email, it said always be ready for a potential extra half an hour. Be ready for that extra half an hour. Okay, so we started at 1:30. We're likely to finish at about 4 o'clock. So go take a 5-minute break, make a cup of coffee, say hi to your mom or your dad or your sister or your brother, whoever you're staying with, okay, or your roommate, and we'll start again in 5 minutes. See you guys just now. Guys, we're going to be starting in 2 minutes. So if you can hear me wherever you are in your room, in your house, or whatever, please make sure that you're ready to start in 2 minutes. Cool, we're starting in 1 minute, everyone. 1 minute, please make sure that you're ready and you're back in your seat in 1 minute. If anyone has any questions, you can ask me now. Just type your question through and I'll start explaining them. Okay, sweet, everyone. Oh, I know we aren't there, but yeah. MRT and the opportunity costs are very much linked. We're going to do that right now. So I'll give you more details of that now. But they are and they aren't. It depends on what you are looking for the opportunity cost of. But the opportunity cost of the MRT are directly linked. Your opportunity cost is either the MRT or 1 over the MRT. Okay? Cool, guys. So we're going to begin. Give me a thumbs up that everyone's back, please. Give me a thumbs up that everyone is back. Right? So just addressing a question, how do we calculate the MRS? Okay, well, you calculate the MRS by looking at the slope of your indifference curve. So you would either be given a graph, right, where you can see the slope of the indifference curve, right? Or you might be given the ability to calculate the marginal utility of X and Y, or whatever is on the Y and X axis, in which case you would then use those to figure out your MRS based on the equation that we covered earlier. Give me a thumbs up if that makes sense to you, the person who asked me that question about the MRF. Cool, fantastic. All right, so we're carrying on with our feasible frontier. So we're going to do a quick numbers example. So let's say that this is Q. We can think of Q as, I don't know, pizza, okay? And we are going to look at this as, this is leisure. Right, so basically our MRS, forget the word MRS, feasible frontier, we're going to sit like this, and let's just create some random examples. Let's say, I don't know, so this is 20, this is always going to be 24. So let's say we're at somewhere in the middle, 12 to 13. And let's say that that makes us decrease our pizza production from 70 to 80. Right? So what does this tell us, right? Along this portion here, if I move down, if I go from having 12 hours of leisure to 13 hours of leisure, then what I see is that the opportunity cost of 1 leisure hour is equal to 10 pizzas, right? Or if I wanted to move in the opposite direction, right, I'm going to see that the opportunity cost of 10 pizzas is equal to 1 leisure hour, which means you could do some maths here and you could say the opportunity cost of one pizza is equal to 1/10 leisure hours. All right, so that is how we, thank you. That is how we move around here. So I swapped my 80s and my 70s. Thank you very much for pointing that out to me, Olivia. Yeah, so is everyone cool? Give me some thumbs up if you're with me. Fantastic, cool. So we've got the feasible frontier, which shows the various options that we can have of leisure and pizza. And so basically, moving up and downwards, we can deduce what the opportunity cost does. And this goes back to the question about the MRT, which we'll define the MRT in a second. But really, before we even define the MRT, let's just look at what it means. If I go from this point to this point, I have to give up 10 pizzas. And if I go from this point to this point, then I get 10 more pizzas. So if I want to produce 10 more pizzas, the opportunity cost of 10 more pizzas is 1 leisure hour, whereas the opposite way around, the opportunity cost of 1 leisure hour is 10 pizzas. Let me know if you understand that. Give me a thumbs up if you do. Please give me a thumbs up if you understand that. Cool. So, right, this changes. I'm actually not going to do any more math numbers, right? But you can see that this, well, we could do a quick one. We could basically say, move from here to here, and we could call that 21 and 22, and we see that we go from 50 to 30. So you can see the opportunity cost here changes. And why does the opportunity cost change? Because of the diminishing marginal product. Remember the diminishing marginal product. It says, as I produce more, I get less output, extra output. So as I give up leisure, at the beginning, when I give up leisure, I'm gonna get a lot of extra pizza. When I go from sleeping 22 hours a day to sleeping 21 hours a day, right? So I move from this side, from here to here, I'm gonna see I get 20 more pizzas. But as I move up, the amount of pizza I get decreases, and that's because of diminishing marginal product. Okay, so yes, opportunity cost can work either way. It depends on what you're asking about. Because there's a trade-off between leisure and pizza. So leisure has an opportunity cost, which is a certain amount of pizza, and pizza has an opportunity cost, which is a certain amount of leisure. Okay, so give me a thumbs up if that makes sense to you. Cool. I think we've got that. All right, we're good. So now we can essentially take this and we can say that the absolute value of the slope of the feasible frontier, right, is going to be equal to the change in Q, change in Y over the change in X that is possible, right? So we're going to call that the marginal rate of transformation. It's the rate at which I can transform it. That's why I just say it's technically possible. And if you want a better definition, right, you can go and look it up. It's the rate at which it's in our notes. It's equal to MRT, which is equal to rate at which one must give up one good Y to get more of another. So whatever, and it doesn't have to be a good, guys. Remember, it can be an outcome, it can be leisure. You can think of leisure like a product, okay? So it's the rate at which I have to give up Y for more X. In this example, it's going to be the rate at which I have to give up Q to get leisure, okay? So what is going to be my MRT at this point? The MRT is going to be equal to, anyone? What is the MRT equal to between these 2 points? Right? Right? 10, because we go 10 over 1. Right? 10 over 1. So the MRT here, MRT equals 10 between these points. Whereas over here, right? Whereas over here, we can see that the MRT, right, is different. Over here, it's 20 and 1. So over here, the MRT would be equal to 20. Okay? So just make sure that you can see that the marginal rate of transformation changes as we move around. Please let me know if this makes sense to you. And if you have any questions, now's the time. Otherwise, I'm going to move on. We're good. All right, great. The MRT, yes, the MRT, as I've written it here, the absolute value of the slope of the feasible frontier is equal to my marginal rate of transformation, and the slope changes. So yes, the MRT is going to be at particular points, between 2 points. Okay, thumbs up if that's answered your private question. Going once, going twice. So the question was, is the MRT the slope of the graph at a particular point? And the answer is, yes, it is. All right, I'm now going to erase the board. We're going once, we're going twice. And so the MRT is increasing as we move this way, yes. And it's decreasing as we move this way. So the answer to your question is, as leisure increases, the MRT increases. And think about it, because as leisure increases, I have to give up more and more pizza because I'm not working a lot. As I decrease how much I work, then the marginal product is going up now because it's the opposite way around. Remember, I'm decreasing my work. So marginal product is going from smaller to bigger. So I have to give up more and more pizza as a result. We make sense of that? Yeah, looking for that? Great. All right. We got lucky there that green was a permanent marker that I managed to just get off. But this permanent marker needs to be turned on. Oh, cool. So we are now going to move to the main part, which is, right, optimization under a constraint problem. Oh, right. So 3.5. Decision making, right? Right, we've got decision making and scarcity. And this is what we refer to as the constraint choice problem. All right, the constraint choice problem. So we are limited by our feasible frontier. That is what is possible. So if you were just, you know, you're able to make pizzas, or you're able to make, or you're able to chill, right? Your options are going to be between those two. Okay. So now so what's the goal? So the goal is to maximize utility given constraint of the feasible frontier, right? So let's draw this. I'm now going to actually do something here, guys. So everyone watch me, please watch me. What I'm going to put on this axis now is going to be consumption. Okay? It's going to be consumption C, right? C. I'll do a little side note here. C is going to be equal to, right? Price times output. Okay, so let's say I own a pizzeria, right? We had pizzas there earlier. Now I'm going to sell those pizzas, and that's going to be my income. And my income is what I consume. Give me a thumbs up if everyone understands this. Okay? Give me a thumbs up if we understand this. I'm just replacing pizzas with consumption. Okay? Because I would sell my pizzas for money and then I would get consumption. So we might have to take the pizzas and multiply it by a particular price, but that's the consumption. So really, we have a choice between consumption and leisure. And that makes a lot of sense, right? You have to choose between making money and consuming goods and services or chilling, right? It's one of the two. Well, some of us are trying to find a way to do both, but it's not always that easy. So we're limited by the feasible frontier. We know that there are lots of options. So I could be here, 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 here. And what if my indifference curves look like this? So first of all, remember indifference curves never slope up. I see one. If I want to maximize my utility, guys, so sorry for just pausing there. If I want to maximize my utility, then do I want to be on the highest indifference curve possible or on the lowest indifference curve possible? Right? Give me an answer. What do you guys think, highest or lowest? We want to be on the highest indifference curve, right? So what I do is I simply say, cool, right? I could sit here or here, but then I'm on IC1. And there are options where I could be on IC2. But wait, if it touches twice, it means that there are even better options. And what we do is we look for the point of tangency. We look for the point of tangency. When I have tangency, what do I know? I know that the slope of my feasible frontier is equal to the slope of my indifference curve. And we can talk in absolute values, but they're both negative, so we don't have to. And when we're at that tangency point, so I'm actually going to take that away. When I'm at that tangency point, I now know that the MRT is equal to the MRS. So when my MRT is equal to my MRS, then I've reached highest indifference curve possible, given my feasible frontier. Therefore, I see that my utility is maximized. I've managed to maximize my utility. So that means that I'm going to consume here, with this being my leisure hours, and this being my consumption. So I'm just going to draw, going to be like a funny L and a C, star and L star, just to represent that those are the amount, that's the amount of consumption, and that's the amount of work that I'm going to do. So I'm going to go back into that. I'm going to say the goal is to maximize utility given the constraints of the feasible frontier. So we want to reach the highest indifference curve possible given the feasible frontier. And we know we've reached that when we get to our tangency point, right? Where the slopes are equal, and we know that means that the MRT is equal to the MRS. So the rate at which I'm willing to trade things is the rate at which I'm able to trade things. And we know that that is the best point to be with regards to our utility maximization. Does anyone have any questions, or do we understand this? Give me a thumbs up if we understand. Okay, give me a thumbs up if we follow this. Cool. I'm looking for either thumbs up or for questions, guys. All right. Cool. So let's just quickly discuss these points. Let's call this A and let's call this B. Right. So let's just say we were at A or B. B can also be here if that is easier for you to draw. Okay. So let's say A and B. So what's the story at A? Someone tell me what the story at A. First of all, just answer me this. Is the MRS greater than the MRT, or is the MRT greater than the MRS? Which one's greater, MRS or MRT? Anyone? How would you figure that out? So what we're going to do is we're going to look at the slopes at point A. Is the absolute value of the slope of the indifference curve greater than the absolute value of the slope of the feasible frontier? And the answer is yes, it is. We can see that the indifference curve is steeper than the feasible frontier, right? So we know that the MRS is greater than the MRT, okay? And we know, therefore, not really based on that, more just based on our graph, we know that we've got too much consumption and less leisure, and not as much leisure. So we should decrease consumption and increase leisure in order to increase my utility. And as I do that, the marginal rate of substitution will get smaller and the marginal rate of transformation will get larger, and we will eventually have them equal. Do we follow this? Please give me a thumbs up if you understand what I've just drawn up on the board there with A. Okay, cool. And then you can note it if you want to, right? The B would be the opposite. Okay, B is just going to be the very opposite of what we've written over here. Okay, cool, guys. If anyone has any questions, now is your time. Therefore, if not, we want to move on. Please explain why MRS is greater from a private question. Cool. So how did I figure out that the MRS was greater? I'm going to erase something. Is it okay if I erase everyone? Give me a thumbs up if we do. Going once, going twice. Okay, I'm going to erase now the top part. So the reason that I know this, okay, so at A, how do I know it? Okay, how do you know that the MRS was greater because the indifference curve was steeper? Well, if the indifference curve is steeper, right, it means it has the absolute value of the slope of the indifference curve is greater than the absolute value of the slope of the marginal rate of transformation. Okay, so absolute value slope indifference curve versus the absolute value of the slope of the feasible frontier. Okay, if I look, yes, you can. So you can just eyeball it. Look, guys, look. One curve at this point is much steeper than this one. I don't need numbers to be able to do that, right? I can see that this is steeper than this line here, right? So I know that this is greater, and therefore I know that the MRS is greater than the MRT. And if we've got a situation like this, I'm answering now the question about, is it bad? Okay, is it bad? Well, it's not bad. It is bad. In a way, it is bad. If the MRS is greater than the MRT, what this means is that if we decrease consumption and increase leisure, we will increase utility. So yes, in a sense, if MRS is not equal to MRT, then you can increase your utility by moving to a different point. In which case, you don't want to stay where you are. If you stay where you are, you're losing. You're not losing, but you're not getting as much as you could. You could just change your situation and you would be able to get more, okay? So that tells us that the MRS not equaling the MRT is not an optimal situation. In other words, it is not utility maximizing. So let me know if I've answered that question. Okay. Okay, I'm going to take a step back here. Again, what is the goal? The goal for this person is to utility maximize. So Olivia, don't think about, is it bad because we would decrease how much was produced, right? Maybe because maybe what you're thinking is more production is a good thing. But it depends, right? It depends on what you want as an individual. Remember, that's what economics is about, the study of how people make the decisions. In this case, we're looking at how would this person get the most utility if they had to choose between consumption and leisure. So there's no, good or bad in this situation. Okay. And then I have one more question, but since they intersect at the same point A, shouldn't the big gradient be the same? So no. So person who's asking me this, that's a bit of a math thing that you've got to go back and review, all right? If they're at the same point, the value at that point is the same, but the gradient is not the same. I mean, for example, this is an upward sloped gradient, but this is a downward sloped gradient. And just because they intersect doesn't mean that the gradients are the same. Okay, the gradient has nothing to do with the actual point itself, rather the change from one point to another point. I hope that answered your question. Okay, sweet. So, guys, we're going to move on now, and we're going to do some changes. So, if you have any other questions, please let me know. Otherwise, what you should do is you should take 30-second break, take a deep breath, run to the toilet if you need to, come back quickly. I'm going to erase the board, I'm going to look at my notes, and we're going to start in 30 seconds. Okay? So let's go. Okay, sweet, guys. So, Matt, that is not relevant to our economics right now, all right? But I'll tell you that I'm not running out of food, that's for sure. Okay, so we are going to move on now. We're going to talk about 3.6, right? 3.6, which is the economic growth in hours worked. Economic growth and hours worked. Okay, so what are we looking at when it comes to economic growth and hours worked? So first of all, how could we see economic growth on the feasible frontier? So if this is my output and this is my leisure, don't worry if I swap between consumption and output and leisure and stuff. What do you guys think? If I have economic growth, in other words, let's say, for example, that there was an improvement in technology, okay? So let's say technology increases. What this means is that there's going to be an increase in the quantity produced at every point. So it doesn't change the fact that there are only 24 hours a day that you can have leisure. But what it does mean is that as you give up leisure, you now get larger amounts of output than you did before. So we see, right? We see this shifting outwards. Okay? Please give me a thumbs up if this makes sense to you guys. Technology is going to push the feasible frontier outward, but it's not going to change the leisure thing, and the difference gets bigger and bigger and bigger. Okay, so now what is that going to lead to? It's going to lead to me moving from one indifference curve to another. And in this example, let's show it like this. Okay, so what we're going to see here in this example, and there are no rules here, right? What we're going to see is that in this example, it led us to go from this point to this point, but we still got more Q. All right. So someone asked me to please explain productivity of labor. I'm sorry, but I'm not going to go into depth about productivity of labor. We did it at the very beginning. Productivity of labor is marginal product and average of product. And if there's an increase in technology, it means each laborer, right, is able to produce more, each hour of labor. So as I give up leisure, I'm able to get more. So that's about as much depth as I can go to into terms of productivity of labor. I hope that makes sense to you. But basically, technology increase means that each laborer is able to produce more. There's an improvement in the productivity of labor. Cool. Right. So that is what our technology and thing, and it's going to result in a movement to new optimal point. Right? Does everyone understand this? We move to a new optimal point here. Okay? And there are essentially two effects. There are two effects that cause that result from this. Okay? So two effects here. So one effect is what we're going to call the income effect, i.e. the income effect, right? The income effect is basically going to say, well, you're able to get there's more grain, more Q for same amount of leisure. Okay? So, sorry guys, and this is actually what I want to talk about. I want to focus on this. Okay? I want to focus on the effect that this had on leisure. Right. So that's what we're talking about here, the effect that this had on leisure. So, the two effects on leisure. Right? Two effects on leisure. The first one is what we call the income effect. Okay, so the income effect turns around to you and says, you're able to produce more output for every level of leisure, right? If you decide to chill for 10 hours a day and work for the rest of the hours, you're going to get more than you did before. So the income effect is essentially saying you're richer, right? There's been an improvement and you're richer. So what do you think the income effect is going to tell you to do? Is it going to tell you to consume more leisure or less leisure? What do you guys think? The income effect told you you're richer. So when you get richer, should we chill more or should we work more? No, we should definitely chill more. So you're right, more leisure. So increase leisure. Okay, but the opposite, but the other effect is the substitution effect, right? Substitution effect. Now, listen carefully and look up at the board. Now, because this thing has swiveled upwards, we see that the absolute value of the slope has increased. The marginal rate of transformation has increased. Now it's saying to you, but hold on. If you decide to chill more, if you consume more leisure, you're going to be giving up even more output than you did before because things are more productive now. So when you give up, when you consume more leisure, you're not giving up 5 units like you did before, because with the new technology, we can produce more. You're going to give up 10 units. Do we understand that? Right? Do we understand that the second effect here was that there's an increase in the opportunity cost of leisure? Therefore, decrease leisure, right? Therefore, decrease leisure. So there's been two effects on leisure, right? The first one is the income effect, which says you're richer, so consume more leisure, okay? But the second effect is the substitution effect, which is saying, no, but hold on, now that there's better technology, right? If you consume more leisure, you're going to be giving up a lot more output than you did before. So there's essentially been an increase in the opportunity cost of leisure. At every hour of leisure, right, there's a higher opportunity cost associated with consuming more leisure. You're giving up more and more than you did before. So we've got these two effects that counteract each other. Do we see that? We've got these two effects that counteract each other. And that's what we're going to be looking at. So in this case that I've drawn here, which effect was stronger? The income effect or the substitution effect? Right? What do you guys think? The income effect or substitution effect? Which one was greater? The income effect or substitution effect? Anyone? And, right? So we're looking and we're seeing that there was an increase in leisure. The income effect that increased leisure, the substitution effect that decreased leisure. So in this example, right, we see that the income effect is greater than the substitution effect. But, right, this is just this example. So the opposite is possible. We're not going to draw that now because we don't have a lot of time, right? But it is possible. So guys, give me a thumbs up if this makes sense to you. Let me know and we can move forward, right? Going once, going twice, okay? Right, going once, going twice, and we are good to go. Okay, so I'm going to erase the board now. I'm going to erase this stuff first. Yeah? Okay. Okay, so just make sure that you write down that in this example, the income effect is greater than the substitution effect. All right. And there we go. Cool. So we want to analyze this, right? We basically are going to get to a point very soon. And just so you guys know, we don't have to, we've got a few more quite difficult things to get through, but not a lot more. So just take a deep breath and understand that we're going to be done. We probably will be hopefully done before 4 o'clock. Okay? I'm going to try and get it done within a faster period. But yes, so what we're going to do is we're going to now figure out how do we see what the substitution effect and income effect is. When there's a change, right? There's a substitution effect and an income effect. This is always the case. If it's a change in the wage rate, if it's an economic growth technology change, right? There's always going to be a substitution effect and an income effect, and these are going to be opposite. So I want to know, can we isolate the substitution effect? Can we somehow figure out what was the size of the substitution effect and what was the size of the income effect? This will give us a better understanding of why we make certain decisions. Why do we decide to increase leisure or decrease leisure? Cool. And how do those income and substitution effects come about? So before we move on, we're going to have to just create a simplified model. Okay. So let's go. 3.7, right? 3.7 is the income and substitution effect. And what we're doing now is we're simplifying this model to make it easier. The main thing that we need to simplify is the feasible frontier. So, simple model. Okay, and in the simple model, what we say is consumption equals my wage rate times by 24 minus T, where T is leisure hours, okay? So W equals the wage rate and T equals leisure hours, all right? So in the simple model, we're gonna turn around and say consumption equals my wage rate times by working hours. And working hours are equal to 24 minus the leisure hours. Cool. So it's a simple model where we're going to keep the wage rate constant. Okay. So we can draw this now on a small graph, right? We can say consumption here and leisure hours here. The maximum leisure hours I can have is 24. And what is the maximum amount of consumption I can have, guys? Someone? Anyone got an answer for me? What do you think the maximum amount of consumption I can have? If I consume 0 leisure hours, then I'm working 24 hours. And if I work 24 hours, then my income for the day, which is going to be my consumption, is equal to, anyone? Going once, going twice. Well done. Wage times 24. Thank you. Or 24 times the wage rate. Okay, same thing. Well done. Okay, so what we see here is this is what we're gonna call the budget constraint. Okay, so these are both the budget constraint. This is it in a equation, and this is it in a graph. Okay, we've got the budget constraint as an equation, and we've got the budget constraint as a graph. Finally, guys, when I give up 1 hour of leisure, how much more consumption do I get? Anyone? If I give up 1 hour of leisure, then my consumption increases by the wage rate. Okay? I give up 1 hour of, if I give up 1 hour of consumption, I'm going to get paid 1 more hour of wage. Sorry, I'm just going to go like that. So if I take the absolute value of the slope of the budget constraint, that's going to be equal to, right, the absolute value of minus W over 1, which is equal to W. And that is the marginal rate of transformation. Okay, W is equal to my marginal rate of transformation. I'm able to transform, right, 1 hour of leisure into 1 wage rate. So remember what the marginal rate of transformation is saying? It's the rate at which I can trade consumption for leisure. So if I want 1 more hour of leisure, I need to give up an amount of consumption equal to my wage rate. Give me a thumbs up if this makes sense to you guys, right? Please give me a thumbs up if this makes sense to you so that we can move forward. All right, cool, awesome. Awesome, 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 awesome. All right, so now we can move forward and we can basically just turn around and look at where's my blackboard. Okay. There it is. Cool. So we're going to carry on this side of the thing. So back to where we were, right? So again, we said that utility is maximized when, right? Utility is maximized when MRS equals the MRT. Okay? So if we use this simple example, right? If that's my budget constraint, okay, this is going to be equal to W times 24, or 24 times W, right? If we then see that that's my highest indifference curve, and I decide to consume here and here, right? I know that the MRS is equal to the MRT, which happens to also equal the wage rate, because we know that our marginal rate of transformation is equal to the wage rate. So MRS is equal to MRT, which is equal to the wage rate. This is extremely useful in a test or exam or problem or anything when you're problem solving, right? You know that at this point, both things are going to be equal to the wage rate. Okay, so will MRT always equal the wage rate? When you're looking at a when you're looking at a consumption leisure problem, then the answer is yes. But if you're looking at another type of problem, then it might not be. Okay? Then it might not be. Now, I have a question. What do you guys think? If this was to be 14 hours, if I'm consuming 14 hours of leisure, how many hours am I working? Guys, how many hours am I working? Or better yet, how much consumption am I earning? Right? If I have 14, great, 10, right? And then 10 times by the wage rate will tell me exactly how much consumption I get. Very, very good. So, cool. We know that it's at this point that we maximize, that we optimize, right? And we do all of our problems as such. Give me a thumbs up if you're following this stuff, and then we're going to erase this and we're going to jump straight into the substitution effect and the income effect. Cool, fantastic. Right, I'm going to erase the board now if that's cool with everyone. Going once, going twice. We're good. Oh, it was a bit late, Olivia. I've erased everything now. What I don't mind doing is working with you afterwards. But all we've really done, Olivia, is we've essentially turned our feasible frontier into a straight line. Okay? We've turned our feasible frontier into a straight line. And we have definitions for that, and I'm very happy to stick around afterwards. But just think of what we do from now on, the straight line as our feasible frontier. Okay, so we are going to do some examples now that are going to move us towards the substitution effect, right? And the income effect. The first thing, though, that we're going to do is we're just going to create an example just to start making sense of the income effect. This is what they do in the book, right? We're going to create an example where we say, if someone gives you a gift, so example, okay, right? Example, and we're doing this to understand example, and it's going to be something to do with the income effect. Okay, so let's say someone gives you, friend gives you a gift of 100 Rand. Okay, friend gives you a gift of 100 Rand. And essentially what we're going to do is we're going to create two different ways in which someone might respond to this. Okay, remember this is leisure time and this is consumption. Okay, with both of these, so we'll just focus on the one for now. We're going to start here. This is 24. This is W times 24. Okay, so if before the gift I had W times 24, then what would the 100 Rand gift do to me? Right? It would simply allow me to have 100 more. So we're going to see this whole thing shift up, right, by an amount equal to 100. So now it's just going to be 100 plus W times 24. Okay? Now, also, answer this question. This is an easy question, does a 100 Rand gift make any difference to what the maximum number of hours that you're able to sleep in a day is? No, right? So we're going to see that this thing is going to shift up, and the slope will remain the same, but it stops here, okay? It stops here, because you can't get more hours in a day. Does everyone understand this? So the whole thing, all it's done is it's shifted up by 100. We've just gone up by 100. Is everyone happy with that? Give me a thumbs up if we understand this. Yeah? Okay, cool. So we've gone up by 100. We don't actually have to draw that. I just want to make sure that you guys see that. Okay? We've gone up by 100 here. The slope has not changed because the wage rate is the same. So the slope doesn't change. Right? The rate at which I can transform leisure into consumption or consumption into leisure, it has not changed at all. Now, let's say someone gives you a gift of 100 Rand. You might respond by doing this. You might respond by going, oh, okay, cool. I have more money. So as a result, I'm going to increase my leisure. I still end up with more income as well, but I'm going to, use a little bit of that 100 Rand to just work less. Does everyone understand that? Okay, so someone's given you 100 Rand, right? Someone's given you 100 Rand, but you've decided to say, you know what? I'm going to take that 100 Rand and I'm going to work a little bit less. At the end, I'm still going to get more. I'm still going to get more consumption. This is going to be less than 100. This is really not a big important detail, but this is going to be less than 100, right? This change from this point to this point is going to be less than 100 because I decided to increase my leisure hours a little bit. Okay, so in this case, right, we had a pure income effect. Now, I just want to say there is no substitution effect here. Why is there no substitution effect? Anyone have an idea? Anyone have an idea why there might not be a substitution effect? I'm going to answer that question now. Okay. The reason that there's been no substitution effect is because what was the point? What happened in my substitution effect? We said there was a change in the opportunity cost. But guys, what defines your opportunity cost? It's the slope of this line. The slope of the line tells you your opportunity cost. Okay? So we don't have to look for a substitution effect because there is no substitution effect here because there's been no change in the opportunity cost. So I'll actually write that first. No change opportunity cost. Therefore, no substitution effect. Okay. Only income effect. Okay. So in this example, we see, so there's therefore no substitution effect, only income effect. So we'll call this example 1 and we'll call this example 2. In example 1, income effect is positive. We increase leisure as a result. Okay? We increase leisure as a result. And all I really want to show you is that you can have a situation where, right, same story, right? But what happens in my example here is that there is no change. So your friend gave you this gift of 100 Rand, and you thought, great, I'm going to put it in my pocket, and I'm still going to work an equal amount. So in the second one, we say that the income effect is 0. No change in leisure. Okay? There's been no change in leisure. Give me a thumbs up if you guys understand. Basically, all we're looking at here is this is an increase in income. There's been no change in the wage rate, so it's impossible to look for a substitution effect because there's been no change in opportunity cost. I keep stressing that. Okay? So any changes that we see here will be due to a income effect only. Now, there are two situations that you can land up in. You can either have a positive income effect if we go out, or you can have income effect equal to 0, and therefore no change in leisure. Please give me a thumbs up if we understand this. Very important that I know that you guys understand this. If I'm not getting thumbs up, then I'm not so sure. So I'm not getting all the thumbs up that I would like. All right. So then maybe I should go through it one more time. Again, the income effect is just saying the income effect is just saying you've been given, when you've been given extra income, this is going to cause you to want to consume more leisure, right? But sometimes the income effect will just be 0. You won't have an income effect. Eventually, if you kept giving this person more money, they might want to consume more leisure. But in this example, we see no extra leisure is required. only in this one do we see we need extra leisure. All right. So I hope that helps. Please let me know if that makes sense. If it doesn't, we're just gonna. I'm sorry. If it does, we're just gonna carry on. Again, someone asked me to explain W times 24. W times 24 is the maximum amount of consumption that you can have. The wage rate times 24 hours in a day. Please let me know if that makes sense. In the example, we then said, well, that increased by 100 because the person gave you a 100 Rand gift. Okay? That's the W times thing. Can the income effect be negative? If we moved in the opposite direction. So thank you, Joanna. This is a good question. If I moved in the opposite direction, if someone came, took 100 Rand away from you, right? Then that's what it would look like. So I think in a past test one last year, they did that. They said, what happens if the government came and took 100 Rand away from everyone? Okay? Then what it would do is it would shift you downwards, right? It would shift you essentially down, okay? And it would say that we go from this point down to a further point, and there would be a negative income effect as a result. Let me know, John, if that makes sense to you. Okay, great. So with all that said, I'm now going to erase this. So if you have any questions, now's the time. Otherwise, we're going to move on. Going once, going twice. Okay, cool. Actually, just one last thing. Why would income effect be equal to 0? Why could the income effect be equal to 0? And it's just a note to make because MRS constant at each MRS constant at this leisure amount. Okay, we can see here the MRS at this point is equal to the MRS at this point here, right? The slopes haven't changed, whereas here, clear that the slopes have changed. That is not equal. Okay, so that is the reason that MRS is constant at this leisure point. It's a very it's quite a detail, and I wouldn't stress too much of it if you're confused by it. So when we have an income effect equal to 0, the MRS is constant at this leisure amount. Cool. I know that it's probably starting to get a bit confusing. Please remember that when you do, just take a break later and then maybe re-look at everything. You're going to find that it starts to make a lot more sense to you. Okay. So we're now going to move towards a change in the wage rate and the effect that this has on consumption and leisure, and then finally break it down into an income and substitution effect. So, change in the wage rate and the effect in the effect on consumption and leisure. Okay. So we're going to do an example now where we say, actually no, we'll do it afterwards. So what is the wage rate? If there's an increase in the wage rate, what will that do to my, right? What will that do to my budget constraints? So let's say the wage rate increased, right? What would that do? Cool. Guys, give me an answer. What's that going to do to this graph? How is that going to change this graph, right? It's going to lead to and I think you mean there's an increase in the consumption intercept. I'm pretty sure that's what you meant. So, Olivia, that's almost full points, right? We're going to see a change in the consumption intercept. We're also going to see a steeper slope. Fantastic. That's exactly what I was just going to say. So the person is happy. Well done, right? We're going to see an increase in we're going to see an increase, a steeper slope. Let's not use the word increase because it is negative. So yeah, so what we've done is we've gone from W what we've essentially done is W1 times 24 to W2 times 24. Okay? So there's been an increase in the wage rate, and we went from W1 times 24 to W2 times 24, where the wage rate W2 is greater than W1. All right. Now, I'm going to take a step back, and I need everyone to hear me. Okay? So in a workshop, I'd be looking and waiting for everyone to look at me, but I hope you're all looking at me now. The effect that this has on leisure can be positive or it can be negative. And it depends on the income and substitution effect. So I'm going to do an example where we're going to say we go from this point to this point. When I go from the first optimal point to the second optimal point, I see a decrease in leisure. Okay? Yes, we are. So someone asked me, are we assuming this person is earning hourly? Yes, that is what we're assuming. Okay? Remember, this whole thing, we could just change it. We could model it on days worked, right? We could look at it in a month, or we can do it per day. So don't overthink that kind of stuff too much. We could change the way we set it up. Right, so we've got to get back to here. So what we've seen is the increase, the wage rate increase in this example has led to a leisure decrease, right? Has led to a leisure decrease, right? So why would that be, right? Well, what is the income effect saying? And this is what I really want you to see. So the income effect of a wage rate increase, right, is saying that that there is an increase in consumption at every level of leisure, right? Therefore, can increase leisure. So therefore, let's just say increase leisure, right? I'm willing to sacrifice more consumption for leisure, okay? So the income effect is that there's an increase in consumption at every level of leisure. Let me add a bit more. So we can say, therefore, willing to give up some C for leisure. So we see an increase leisure, right? But there's another effect. Okay, the other effect is my substitution effect. And my substitution effect is saying, right, that there's been an increase in the opportunity cost of leisure. Because think about it, guys. I hope you're hearing me. The wage rate has gone up, right? If the wage rate goes up, it means that every hour you decide to chill, you're giving up more, right? So the opportunity cost of leisure has gone up. Are we cool with that? Please give me a thumbs up if you do, if that makes sense, right? So therefore, willing to give up some leisure for consumption, which is the opposite, right? This is the opposite of that. And that means it's going to have the opposite effect, decrease in leisure. Okay, so what do you think has happened here? if we see that in this example, we've had a decrease, right? Then it means the income effect is greater than the substitution effect. All right, so let me know if you guys make sense of that, right? And if you do, then I'm going to erase the board and we're going to break this thing down much more intensely. So we've got an income effect and a substitution effect. Okay, the income effect is saying when the wage rate goes up, it's saying we have more consumption at every level of leisure. So I'm willing to give up some consumption. Okay, and if the increase in the opportunity cost of leisure, if the substitution effect of the increase in opportunity cost of leisure means I'm willing to give up some leisure for consumption, right? Then in that case, I'm going to decrease my leisure. And yes, right? The answer is the other way around. The substitution effect in this example was greater than the income effect. I decided to work more as a result of this. Okay, everyone's good? If you're good, I'm going to erase the board now. So we're going once, we're going twice, we're going to break this one down, and then we're pretty much going to be done for the day. So we're going once, going twice, and done. Cool. Okay, so now we have to actually break it down on the graph. So this final part of the workshop is about how do you break down the consumption, the income effect and the substitution effect on the graph. And what I would suggest is actually think, I would probably say that it would be best to take a seat, sit back. So if you're on top of your game, follow me, draw everything I draw. But if you're like getting a bit lost and confused, it might be worth now just taking a step back and not worrying too much about drawing the graph, because you can get this graph out of the textbook and elsewhere, where you can just take a picture or you can take a screenshot, right? And you can do it later and just focus now. Okay, so we're going to break down the example that we just created. All right, so we saw that we swiveled outwards. Okay, we swiveled up. So that's still 24. Sorry, I just want to get this right. Okay, that's still my 24 points. And this was because of the wage rate increase. I'm not going to fill that out because I think you guys know that. All right. So I just want to insert point here. Okay. And now we saw that the effect was to go from this point here to a point up and to the right. And I'm not going to lie, to get this drawing perfectly isn't the easiest, okay? It is not the easiest thing to do. Sorry, so you're going to see again that I'm struggling here to get this the way that I need it to. Okay, and hopefully that's going to be good enough. So we went from this point to this point, right? All I've done is actually just made a bigger version of the same graph, right? This is just a bigger version of the same graph that we did earlier. Is everyone happy? Okay, so now how do you find the income effect? Okay, how do I find the income effect? To find the income effect, right? Everyone must be with me now. Please pay attention. To find the income effect, we want to say Imagine, in fact, before I write it out, we're gonna do it in words. We're gonna say, imagine that instead of this being a wage rate increase, right? Instead of this being a wage rate increase, we were able to get to the higher indifference curve, the higher utility level, by simply receiving a gift. Yeah? Do you understand what I just said? Give me a thumbs up if you understand what I said. Could I get to indifference curve 2 by just being given a gift? Okay? And then we pretend like that happened. So if I was given a gift, the original budget line would shift, our budget constraint would shift upwards parallel. Okay? So I'm going to keep shifting up parallel until I touch that higher indifference curve. So then I want to draw that line. It's always hard to get this perfect. Okay? So we shift this upwards, right? From our old budget line, our old budget constraint, to the new indifference curve. Okay? So that's going to be the rule we're going to use. We're going to shift old budget constraint to the new indifference curve. Because this would say no change in opportunity cost, which is my wage rate, but we still managed to get to higher utility. So that would show me the income effect of the wage increase. The income effect of the wage increase is saying, but imagine that it actually wasn't the wage increase, and you were simply able to get to this happier point, but without a change in the opportunity cost. No change in opportunity cost. Okay? Then in that case, right, we would go from this point to this point. So this would be my income effect. This would be my income effect, going from this point to this point, right? Give me a thumbs up if we understand how that's the representation of the income effect. Because we were able to go from indifference curve 1 to indifference curve 2, but with no change in the opportunity cost. In other words, we shifted the old budget line, right? We keep budget constraint slope constant. Then we were able to go from this point, which I'll call point A, to this point, which I call point B. But we have a problem, right? And that is, this is not reality. B is a dreamland, okay? If you get what I mean. And what actually happened was the wage rate increased. And so we can now see that going from A to B was really due, or going from IC1 to IC2 was really due to the change in the wage rate. So this is the income effect that occurs from this change. Then the substitution effect is going to occur from B to the final point, C. Remember, we knew that we started at A and we landed up here. We already knew that, okay? Now, though, what we're doing is we're showing, oh, this point, this change is caused by an income effect that goes this direction and a substitution effect that goes in this direction. And in this example, we can see that the substitution effect is greater than the income effect. And that has resulted in a net effect that is in the direction of the substitution effect. Okay, so that's quite a lot of detail. I'm going to address questions. I would appreciate, guys, I'm getting a lot of private questions. Please send your questions to the chat room so that everyone can see to everyone. You have no reason to be embarrassed by your questions, okay? The first question was, how did you know that second dot had to be to the right of the first dot? Okay, good question. So how did I know that when we went from A to B, it was to the right? Well, because of the example we did earlier with the gifts, remember, if my budget constraint shifts out parallel, then either I'm going to have zero income effect or I'm going to have a positive income effect. So I knew that it was going to be out and to the right, right? Or at least directly up, but I chose to draw it positive in this example, okay? So Mr. who asked me the question there, right? Do we understand why this was to the right? Cool. Second question, do we draw everything with the intention of BL1 being tangent to IC2 at a different point than BL2 and IC2? Yes. So that is the point. When you shift this budget line up, which I should actually give it names, right? So this was BC1, this was BC2, okay? And the red one you can kind of think of it as BC1 but dash, okay? It's like an edited version of BC1, okay? BC1 dash. So what we did is essentially we shifted our old budget line up to touch the new indifference curve. But given the slope, given the way the indifference curve slopes, that's always going to be right out and to the right of the other point that we've got there. So person who asked me that question, let me know if that makes sense to you. And if it does, then we're good to go. Okay, guys, type in the chat if you just say I just don't get it. Just say that's me, right? You can type to me privately if it's just I don't get it. Okay? Is there anyone who just doesn't get it, or are we good? Because sometimes I don't get questions because people just are absolutely confused. I think we're good. All right. So the main thing to understand is to find the income effect. We shift, right? We shift the old budget line to touch the new indifference curve so that there's no change in opportunity cost, but we can still see the higher utility. All right? That is how we're able to do this. So I'm just going to write a few more notes here about this thing. So essentially, how do we see the income effect? The income effect is the change in leisure if, right? So, sorry, let's actually write it out a bit better. Income effect is the effect of the change in the wage rate on leisure if there was no change in the opportunity cost. So the income effect is the effect of the change in the wage rate on leisure if there was no change in the opportunity cost. Okay? In other words, right? If there was also no change in the slope of the indifference curve at the optimal point. Okay, so you can see from A to B, we've got no change in the slope there. We've got no change in the slope there. So no change in the slope at optimal point. Or you can even think of it as no change, rather think of it as the no change in the MRS or no change in the MRT at the optimal point. Okay, which means the slope of the indifference curve. So the slope of the indifference curve wasn't wrong. I just wanted to give you this as well. Likewise, the substitution effect, right, is the effect of the change in the wage rate, or the effect of the change in the opportunity cost, right, when utility is when at higher utility. So the substitution effect again is the effect of the change in the opportunity cost when at a higher utility level, right, on leisure. So the effect on leisure, the effect that we've got on leisure caused by the change in the opportunity cost, but at the higher point. And that is the example finished. So should the wage decrease, would B be to the left? Yes, exactly. If the wage rate were to decrease, we would see B to the left. All right, guys. Are there any other questions? Give me a thumbs up if everyone understands what's going on or feels like they can go now and they can relook at this and they're going to be able to get it solid. Okay, awesome. Awesome, guys. So what I want you guys to take note of is that in my example, the income effect was greater than the substitution effect. But I could have drawn it where the substitution effect was smaller, right? And if we had more time, we would do such an example, okay? Where we would see that the substitution effect simply doesn't go all the way. In that example, right, your C would just be between A and B, but up here, okay? So in that situation, we would have a positive effect on leisure. All right, but we can still be on the left with a wage increase, right? Yes. So again, the fact that we went from A to B, from a wage increase, or from A to C is possible, but we could have also gone out into the right or vice versa with a thing. Cool. Yes, I think the answer is yes to that question. Okay, so I'm going to keep answering. Is income effect greater than substitution effect? No, in this example. So in this example, the substitution effect was greater than the income effect. You can see that right here. Do you see that? Kalame, do we see that? Cool, awesome. Okay, so it depends on preferences. Yes, it depends on the shape of the indifference curve. If the indifference curves were shaped differently, then it would land up being different. So, you know, if I was in a test workshop and we had more time, we'd probably do 1 or 2 more examples, but we have run out of time. But please be sure that if you guys ever get tested on this material, right, we will run further workshops to ensure we can go through more examples, right? But this base example should explain to you all the dynamics. Now, what I think you guys should go do is make sure you read in your textbook about the rest of the various different examples that can occur. They all look pretty much like this. It might just be in opposite direction. So just go check it out. Also, please make sure you read 3.8, 3.9, and 3.10. I have not covered those sections. They are very basic. There's not crazy graphs. And also make sure you just check out your slides to see that, that everything that you've got is in order. Otherwise, guys, I'm going to hang up for questions, but I'd like to say thank you all very much. I know that it might have at times been a little bit confusing because it's quite difficult work, but I hope that you found it useful. I really hope that you found this workshop good. Give us some feedback at some point if you can. Otherwise, thank you all very much and have a wonderful afternoon and evening. And I look forward to seeing you guys for the next workshop, which I believe is on Thursday when we'll be covering Unit 4. Awesome. It's a pleasure, Olivia. Thank you very much, Olivia. Thank you, Matt. Right? Thank you guys for joining today. Abigail, I appreciate you all. Guys, it's tough times for us all out here, so please encourage your friends to join for these online workshops. They really are how we are surviving as a company. So if you can tell your friends about our workshops, we really appreciate it so much. If you have any friends out in Stellenbosch, please tell them that we're running workshops for them as well. And yeah, I just want to guys say thank you again. Thank you, thank you, thank you. We will continue to run these workshops for all the courses that we run workshops for. And yeah, we'll continue to make sure that we're there for you guys. So I'm going to hang out. If anyone has a question, just pop me a message. Hang out for one or two more minutes. Otherwise, at that point, I will end the meeting. But yeah, guys, thanks again and have a blessed afternoon. Wish you all the best. Can you please explain why the substitution effect would be 0? Oh, do you mean the income effect, Abigail? Abigail, let me know if you mean the income effect. Are we talking about where we had an income effect equal to 0 from that old example, from the previous example? You need an answer to that? Abigail? Oh, sorry, now I understand. So why didn't we look at the substitution effect? Abigail, so that's why. So in that example that we did, we had the budget constraint shifted out, right? And the slope didn't change. So remember, you only get a substitution effect if there's a change in opportunity cost. If there's a change in opportunity cost, then we're going to see a substitution effect. So in that previous example, we didn't see a change in the opportunity cost because of the gift led to the budget constraint shifting out parallel, right? So there was no change in the slopes, there was no substitution effect. It's a pleasure. And that was the whole point of that example, to show you, to find the income effect, we've just got to keep this thing with an equal slope. Then we can go out and find the income effect. The move from that point to that point is then the substitution effect. So your substitution effect is always on the new indifference curve, from one point to another on the new indifference curve, and the income effect is the jump from one indifference curve to another. So Abby, so I just got to ask a question for those of you that are still hanging out. How do we know where the tangent points on the indifference curve are for the budget constraint? So I'm going to tell you the truth. It's quite difficult to draw. You have to have this thing in your mind in advance. So for those that want to hang out, let me give you a little bit of a drawing lesson. Okay, I'm going to give you a small drawing lesson. So basically, right? Basically, when I draw this thing, my first thing is I know that because I've increased my wage rate, I'm going to go out like that. So that's how my budget lines are going to move. Okay? But then, and this is just a terribly drawn one. Okay. So then, I know that I'm going to be drawing a particular type of example, right? So in an example, right, so when I do this, I know that I want to move from one point here to another point here, because I want this to be my net effect, okay? I want this to be my net effect. Now, I need there to be a positive income effect. So I draw a little dot out here, okay? Then I look at the slope here and I say, right, I need the slopes to be the same here, okay? Then, once I've done that, I can draw my indifference curve to satisfy basically what I'm looking at. So I go down and I make this tangent, and I carry on, and I make that tangent. Then I draw another curve, and I just make sure that it's tangent to that curve. Now, when I want to draw this other budget line, I can simply take this out and draw it as such. And now I'm able to have a positive income effect with a larger negative substitution effect, which yields that as my net effect. Yes, so they would have told you. So they would have said, explain using the substitution effect and the income effect why the wage rate would make someone, why an increase in the wage rate would make someone work less. That would be the question. Using graphs, show through an analysis of the substitution effect and the income effect why a wage rate increase would cause someone to decrease leisure. Okay, so they would have given you this. They would have told you what the net effect is in advance. Might not have given you numbers, right? They would have just told you what the net effect was, and then said, explain how that's possible, and you would draw it as such. Great, no problem. Thank you very much. Cool, guys. Are there any other questions? Everyone's good? Give me a thumbs up if you are with me. How do we decide which side of the new point we draw tangent to the new budget line? Okay, to make sense of this question, someone asked me, how do we decide which side of the new point we draw tangent to the budget line? Do you mean like if I'm on this side of the point or if I'm on this side of the point? Abigail, I'm kind of confused as to what you mean. But yeah, it does depend on the question. So I'm going to rather say, so imagine a question said this. I'll type it even. Say, question says, using graphs, show how a wage rate increase could cause someone to decrease leisure. And maybe they'll say break down the substitution effect and the income effect. So that could be the kind of question that you could be given. And then you're going to say, okay, cool. I need this to be my starting point, and I need my end point to be negative. I know a wage rate increase will swivel my budget line upwards, right? So I know I need to go from there to there. So I need to show, though, that the income effect would have been positive, but that the substitution effect was greater, okay? So that is how we do this, right? We look at this, we get a question like that, and then we break it down accordingly. So they've given you, they've said, show how the wage rate increase could cause someone to decrease leisure. How is this possible? And you break it down as such. Let me know if that answers your question, or if you're happy with that. Abigail, let me know if I've answered your question as well. Okay, cool. Anybody else? Andrew, you're just hanging out, which is fine, but just let me know if you have any questions. All right, cool, guys. Well, I think with that done, then I'm going to give 15 to 20 seconds for the last question to come through. Otherwise, I'm going to end this. So, yeah, I think that's all, everyone. Thank you very much, Abigail, right? Thank you. Andrew, Sikalame, everyone who was with us today, thank you all very much. We'll see you guys another day. Cheers. Bye-bye.